The night of October 19th, 2017. High on the summit of Haleakala, in Hawaii, a sentinel was watching. It was the Pan-STARRS telescope, a high-tech eye searching for threats and wonders. On this night, it found something new, something strange. This was not a comet. It was not an asteroid. It was a high-speed anomaly, moving faster than anything astronomers had ever seen in our solar system. Its very name, bestowed by its Hawaiian discoverers, told its story, Oumuamua, a messenger from afar arriving first. For millions of years, every object we've ever seen orbiting our sun has been a loyal servant, bound by its gravity. They follow elliptical paths, always returning to our neighborhood. But Oumuamua was different. Its speed was a blistering 196,000 miles per hour, far beyond the escape velocity of our solar system. It was following a hyperbolic trajectory, a one-way ticket through our cosmic home, never to return. This was the unmistakable signature of an interstellar visitor, a celestial vagabond. The moment it was discovered, it had already passed the sun and was speeding away. Scientists had just a few weeks to study this one-of-a-kind object. A rapid response campaign was launched, with telescopes around the world pointing their gaze at this fleeting point of light. But the data was incomplete. The questions would far outnumber the answers. The first attempts to understand it were a comedy of errors. Initially, it was classified as a comet, but there was a problem. It had no coma, that fuzzy atmosphere of gas and dust that defines a comet. It was reclassified as an asteroid, but then it did the impossible. As it passed the sun, astronomers detected a slight, yet unmistakable, non-gravitational acceleration, a little speed boost. This is what comets do. Their icy surfaces warm, they vent gas, and it acts like a tiny rocket thruster. But Oumuamua was inert. It had no tail, no visible exhaust. It was accelerating like a comet while looking like an asteroid. This was the central paradox, a fundamental contradiction that forced the scientific community to re-evaluate everything they thought they knew about objects from other star systems. We couldn't see its shape directly, but we saw its light. Over the course of a few hours, its brightness fluctuated by a factor of 10, an unprecedented range. The only way to explain this was that it had an extremely elongated shape, perhaps 10 times as long as it was wide. A cosmic cigar, or a thin, flat pancake. And it wasn't just spinning, it was tumbling chaotically through space. Its surface was dry and reddish, the result of millennia of exposure to interstellar radiation. It looked like a cosmic relic that had been baked by the universe itself. With no simple answer, scientists went to work on a range of new, natural theories. One idea is that Oumuamua is a fragment of a larger body that was ripped apart by the immense tidal forces of its parent star. This tidal fragmentation could create the extreme elongated shape we observed, but that still didn't explain the acceleration. The leading theories all proposed some sort of exotic, invisible ice, a hydrogen iceberg, a nitrogen iceberg, or even water ice that had been cooked by cosmic rays. Each theory could explain the mysterious thrust without a visible tail, because the gases would be undetectable from Earth. But each theory had a fatal flaw. Hydrogen ice wouldn't survive the long journey. The numbers for a nitrogen iceberg just didn't add up. And the water ice theory didn't explain why the object's rotation didn't change. None of the natural explanations could account for all of its weird properties at once. This is where the story took a dramatic turn. In the absence of a simple natural explanation, a more radical theory was proposed by Harvard professor Avi Loeb. He argued that if an object's properties were so strange that no natural explanation could fit, perhaps the simplest solution was that it was unnatural. Loeb proposed that Oumuamua was an alien-made solar sail or a reconnaissance probe. The solar sail would use the pressure of sunlight for propulsion, perfectly explaining the smooth acceleration without a visible tail. The extreme aspect ratio would make sense if it was a very thin, flat light sail designed to be pushed by stellar radiation. The idea captured the public imagination, but the scientific community pushed back hard. They argued that there was no direct evidence, and that a species advanced enough to build such a craft would have more efficient ways to explore the cosmos. And when we pointed our radio telescopes at it, we heard nothing. No communication, no signal. As a crucial piece of context, the story of Oumuamua didn't end with its disappearance. In 2019, and again in 2025, we found more interstellar visitors. They were named 2I/Borisov and 3I/Atlas. And they were boring. They behaved exactly as we would expect an interstellar comet to behave. They had beautiful comas. They were outgassing as they approached the sun, and their properties all made perfect sense. The arrival of these two normal visitors solidified the fact that Oumuamua was the true statistical anomaly. It was the odd one out, the one that still defies a simple explanation. The legacy of Oumuamua is not just a mystery, but a revolution. Its fleeting visit has laid the groundwork for a new era of proactive exploration. The forthcoming Vera C. Rubin Observatory in Chile, with its massive camera, will be a game-changer. It's predicted to find dozens of interstellar objects every single year. And we're not just waiting anymore. Scientists are already designing missions, like the one proposed by the Southwest Research Institute, that could one day intercept a future interstellar messenger, to get up close, to finally answer the deepest questions about their origin, their nature, and what they can tell us about our cosmic neighborhood. Oumuamua was the first messenger, and its strange, silent passage has changed our perspective on the universe forever. The mystery it left behind is a challenge, a sign that we are only just beginning to truly understand the vast and vibrant cosmos that we live in. So what was Oumuamua? A fragment of a distant star, or a reconnaissance probe from an unknown civilization? The answer remains a mystery. But its fleeting visit has proven one thing. The universe is sending us messages, and we're only just beginning to learn how to read them. The next messenger could arrive at any moment. If you want to be here for the next cosmic story and the next big discovery, be sure to hit that subscribe button and turn on notifications. You won't want to miss what comes next.